Everybody, in this video, we'll begin to deal with the Min-Heap insertion already. So the same number that we are dealing with the max heap earlier. So however, the run through for this one is actually Min-Heap. So that is actually expected that that the lowest value will be serving as the parent node in every structure. So we'll begin to do the heapify if ever that it will have some violation. So let's try to work on this first. So 25 that is considered as Min-Heap already. So 25 and 50, we can insert 50 at the left side because we are following the complete binary search tree. As what we have mentioned, that complete binary search tree will begin to insert that from the left to right particularly. So of course, we'll not begin to work on like the binary search tree principle. We'll not begin to follow that here then. So 25 and 50 that is following the Min-Heap, so there is no violations pertains to that. We will begin to proceed with, we're done with 25 and 50, we'll proceed with 70. So 70 will be placed at the right side of 25, so therefore 70 now is 25, so that is following the Min-Heap principle. So we're done with this 70. So what will gonna happen? We're done with 25 and 50 and 70. We'll proceed with 30. So 30 will be placed at the left side of 50 because of course that is the last that is the left sub tree, and then 30 is will be inserted here, and we'll compare it into the root node, and root node is giving the largest value, highest value, so we can definitely do that. We can definitely do a heapify right now. So we can swap 30 and 50. So what will gonna happen? 25 and 30 will go up, and then 50 will go up. I go down rather. So 70 will be here, so 30 and 25 comparing, so that is actually in the right structure. So therefore, there's nothing that we can do for that once we're done with the 30 already. So for 20 right now, we'll begin to insert 20. Also, and 20 will be placed here then in the right position of 30. So we'll begin to copy as is, then 20 will be here. 20 compared to 30, and 30 do have the highest values. We can definitely heapify, swap them. So 20 will go up, and then 30 will go down. I'm so sorry. Since we're following the Min-Heap structure. And then 30 will go down here, and 70 will keep as is. Now, 20 is actually, we'll begin to compare that into the root node, which is 25. So 20 is actually less than the value of 25. So we can definitely do the heapify. It will become, we can swap them. So 20 will be the root node, and 25 will go down, and then keep as is with the 70, and keep as is with 50 and 30. So right now, if we begin to see this one, we're able to follow the Min-Heap principle already. So we're done with the 20. We'll insert right now 10. So where can we insert 10? I'm so sorry. Keep, we'll copy this first before inserting 10. So 50, 30, and 10 will be inserted the left side of 70. Comparing 10, 10 and 70, 70 do have the highest value, so we can do the heapify method. So swap 70 and 10, 10 will go up and 70 will go down. And then what will gonna happen? Keep us is for 50 and 30. And then right now we're done with that one. We compare the 10 to the root node. 20 is the root node, and then that's actually a violation. We can swap 20 and 10. So 25, then 20 will go down, and then afterwards 50, 30 will keep as is, and 70 will keep as is also. So for this one, since we're able to work on this already, and there's no violation, since 10 is has become the new root node, what will gonna happen? We'll perform 90 right now. We'll insert 90. Where can we insert 90? In the last leaf, the next last, in the next of the last leaf node. So last leaf node is actually placed in the left side, so therefore we can place that into the right side order. So 70, then 90 will be here then. So comparing 90 into the root parent node, that is 20. So of course there's no violation that happened. So we can leave as is. So we will begin to insert 63 right now at this point. So 10, and then 25, then 20. Keep we'll just have to copy first before we'll begin to perform the insertion. 70 and 90, then our value will be 63, and 63 will be placed here then into the left leaf node of left sub D. So 63 is we'll be going to compare that into 50, and we're following the Min-Heap principle since 63 is like having the highest value than 50, so there's nothing that we can do. Now, you will begin to insert 45 right now, 45 after this one. Then copy as is 25, 20, then 50, and then 30, 70, and 90, keep as is. 63 will be here and 45 will be here. Sorry, let me just check 45, yes, correct. Now, 45 compare into the root node. So that is actually a violation because the parent node is actually greater than, so we can do the heapify method. So what will gonna happen? 45 will go up, and then keep as is for 30 and 70 and 90 keep as is. And then 50 will go down, 63 and 50. So this is actually, how does that work? 45 compared to 25, and that's not a violation. So let's continue the process for insertion. Next will be 59. So where can we insert 59? And under the 25, 20, and then 45, 30, and then 70 and 90, and then 63 and 50, and then right now here we can insert this 59. So by comparing 59 to the root node, which parent node, which is 30, so there's nothing that we can do because this is actually following the Min-Heap principle, so therefore we are done with our insertion. So this is actually the insertion right now. Hopefully that you were able to understand that carefully, and make sure to really be aware of the implementation of the Min-Heap insertion. Thank you so much, and I'll begin to work on with the deletion in the separate video. Thank you, and see you in there.